Welcome back. Now this is new problem to find the median, and here we'll try to find it by using graphical method. So problem is like this: house rents in hundreds are given. So 110 hundreds means in short 11,000. So there are 13 such houses with 11,000 rent, then 12,000, 13,000 this way. So the frequency pattern is not like as usual normal. It is like 13, 17, 22, 14, 8, 6. So the second half tail is with lower frequencies and more numbers. First three classes itself contribute more in the entire distribution, and next three classes are comparatively lesser. So here we need to find the median of this. Okay, so to find the median using graphical method, we need to calculate both kind of frequency, that is less than cumulative frequency as well as more than cumulative frequency. So first let me find out less than cumulative frequency. So this is 13 as like less than, then this gives me 30, 52, 66, 74, and then 80. So even if we calculate in this way, this is also correct. So the less than cumulative frequency we have found is this way: 13, 30, 52, 66, 74, 80. Okay, again considering 80, the 80 plus 1 by 2 gives you 40.5. So we may expect our value, I mean 40.5, this element. So the 52 will be the nearest one to the 40.5, which is higher than 40.5. So the value of mode we expect it to near to 130 or 130 itself. Then to find more than cumulative frequency, so for more than cumulative frequency, you can directly have here the highest value, or we can start with this frequency and go on adding in this way. Okay, this is also fine. So if you start with the highest frequency, then 80 minus 13. So this 80 minus 13, this gives you 67, minus 17 gives you 50, 50 minus 22. So this gives you 28, 28 minus 14 gives you 14, and 14 minus 8 gives you 6. So this is correct. Anyway, it is this frequency, these two frequencies, then this total and these two frequencies should always match. Then only you can say you are less than cumulative frequency, more than cumulative frequency, and total. All these three things are tallied, and those are correct. Okay. Now I need to draw graph of these two cumulative frequency. So this is my y-axis, and I'm trying to draw a straight line. This is my x-axis. Yes. So our x-axis gives us the values of x. X-axis is for the values of rents here in this case, and y-axis is for. Okay, so we have calculated less than cumulative frequency and more than cumulative frequencies. Now these two frequencies we have to plot on the graph, and by using this graphical method we have to find the median. So we have to locate the median. So now look at the values in less than cumulative frequency and more than. So minimum value here is 13. Here we have minimum value as 6, and then the maximum value is 80. Okay. So now in this case, our y-axis will represent frequencies and x-axis will represent the range of all these houses. So what we need to do is, we need to have the maximum value 80 on the y-axis, and on x we need to have with the interval of 10, we need to adjust those 6 values from 110 to 160. So in this way we have to find, you have to fix your scale. Okay. So now consider here, so now let me take a scale of 1 centimeter where I consider for 10 frequencies on y-axis, and for 1 centimeter on x-axis I consider again the rent difference of 10 hundredths. I mean into 100 actually. So let me write my scale here. On x-axis, 1 centimeter is equals to 1000, which is nothing but actual difference is of 10, and that is given in 100. So it's like 10 into 100. And then y-axis, which is my frequency, that is 1 centimeter is equals to 10. So this is how I have fixed my scale of the graph, x-axis versus y-axis. So these points are like this: the frequency, and then the range are 110, 120, then 130. Okay, so hope you are clear with what axis I have chosen. So as per the availability of the portion of your graph paper, you can select the scale. Okay, so now first we will plot the points of less than cumulative frequencies and we'll form a curve. Then we'll plot the points of more than cumulative frequencies, and then again we'll form the curve. And the intersection of these two curves, we are expecting them. Anyways, the less than cumulative frequency is increasing, more than cumulative frequency is decreasing. So these two curves and their intersection, that will give us the value of median. So for 110, our first value is 110. For less than cumulative frequency is 13. So somewhere if my 15 is here, then my 13 would be here. So this is the point for 13. Then for 120, which is 30 exact, 130 is 52. So my 50 value is here, just above it. So you should be careful to the points, especially which are in the central classes. Okay. Then for 140, less than cumulative frequency is 66. So 60 is coming here. In the middle, there would be 65. So here somewhere it would be 66. 150 would be 74, exactly in the middle of 70 and 80. And 160 is 80. So the points which I have, so these are the points of less than cumulative frequencies. So let me join them. So this is the curve I have got. Now we'll plot the points for more than cumulative frequencies. So starting with first 80. So for 110, start here with 80. For 120, it is 67. So 60 comes here, 65 in the middle, 67 would be somewhere here. Then next for 130, it is exactly 50. So it is the common point here. So actually it comes here, 50. On the same line. So for previous curve we have got it for 52, and for this thing we have got it at 50. The next value is 28. So 30 comes here. then little below it there is 28, then 14 and 6. So 14 value, so 15 comes here, so here it would be 14 and then 6 would be somewhere here. So these are the points we have got for more than cumulative frequency. So if you join them, the curve is like this. So this is the curve we have got. So this is our less than cumulative frequency and this is more than cumulative frequency. So the curve intersection we have got is very much near to 130. So somewhere just specifically if we see here, so it is very much near to 130. So the points come almost near to 120, 130. So this is the point where we have got median by using graphical method. Okay. So anyways, if we find using n plus 1 divided by 2th term, so that gives you 80 plus 1 by 2, that gives you 40 point something. And in less than cumulative frequency, you would obviously mark for this class for 40 point something, and that gives you median 130. And by using graphical method as well, you get it at the point very much near to 130, almost 130. So this is how you find median using graphical method. So median using graphical method is possible only when we have data given in the form of x and f. In the case of class intervals, we cannot find median using this graphical method. In the case of values, the actual values of x are given along with the frequency, then it is easy to plot it using graphical method. So you might be asked to, using graphical method as well as normal method, find the median. So in this case we have to solve it in this way, and then anyways n plus 1 by 2 gives you the same term. So hope you have understood this example. Then we'll go for the next example where frequencies are given in the cumulative form and we have to extract the normal frequencies and go for the calculation of median. Now this example is given along with class intervals and one kind of frequency. Okay. So this is actually cumulative frequency given. So from number of articles processed and cumulative frequency of number of persons processing, this is the given data. So there, I think width of the class is 20 everywhere, you might have observed, and the frequency is this way, and it is mentioned it is cumulative frequency. So anyways we require cumulative frequency to calculate median, but we require less than cumulative frequency. Now what is the major difference between less than cumulative frequency and more than cumulative frequency? Is that less than cumulative frequency is in increasing order and at the end you have total. And more than cumulative frequency is in decreasing order. So now if you look at this, so this is in decreasing order, so it is more than cumulative frequency is given to you. So from more than cumulative frequency, we have to find out the normal frequency. So we have to extract the normal frequency between them. So let me add here one column called as f, so which is my normal frequency. So from more than cumulative frequency, what we have at the first frequency is the total of all the frequency, and the last frequency is the actual frequency of this class. So if you go on finding the frequencies here, you may expect this frequency here as well. Okay, so now the difference between these two frequencies, so this 180 minus 170 gives me 10. So this is how we have to find the actual frequency of this. So the actual frequency of this class is, anyway it would have got added with the previous all. So this, the difference between these two, here we have got the actual frequency. Then this 170 minus 140. So this gives me 30. So this would be the actual frequency of this class. Then 140 minus 70, that gives me 70. So this would be the actual frequency of this class. Then 70 minus 70 minus 10, the difference between them, that gives me 60. Okay, and this frequency is actually in the more than cumulative frequency is of the same class. So this gives me 10 itself. Okay, so this is how we have calculated the actual frequencies. Now if you can add all of them and check whether that gives you 18. Yes, so this gives you 180, which is equal to the sum of them. Okay, so now here you have calculated the actual frequencies. Now what else we require to calculate the median? We have to calculate the n plus 1th term. So this is 180 plus 1 divided by 2, that we need to find, and then we need to match it with less than cumulative frequency. So here we have to find the less than cumulative frequency using the actual frequencies. Okay, so this gives me 10, this gives me 10 plus 30, 40. So this gives me 110, 170, 180. So here I have calculated less than cumulative frequencies as well. So my n plus 1 divided by 2th term would be 180 plus 1 divided by 2. So that is 181 divided by 2 gives you 90.5. So then we have to find the class whose less than cumulative frequency is just more than 90.5. So among them, so this is the class where we have cumulative frequency just more than 90.5. Alright, so this is my median class. So my median I would expect from this particular class. Now how would you find? Using the same formula, that median is given by the lower limit plus the index n plus 1 by 2 minus the cumulative frequency of the previous class divided by cumulative normal frequency of the median class into I. Now once you have found the median class, we know that lower limit is 120, the index what you have found is 90.5 minus the previous cumulative frequency is 40 divided by its frequency, the normal frequency of this class is 70, and into I, the width of the class is 20. Alright, so you can further solve this and you can find the actual value of median. So you should be able to find the normal frequencies from any given frequencies. Even in the case if only less than cumulative frequency was given, then in that case we should be able to extract the normal frequencies from less than cumulative frequencies, and then you have to apply the same formula, substitute the values, and then you will find the value of median. So hope you have understood all these examples of median. Alright, so try to solve these examples by different method. Try to solve also the examples given in the notes. Then we will meet in the next video with new concepts. Till then, take care of yourself, take care of your family members, follow